Okay, I'm going to run through these very quickly. Most of the attendees have already been at the first two sessions. I can see from those who are on the line at the moment. So the presentation today is from Alastair, and I'll give you a quick description about his background in a minute. But basically what he'll be talking about is a platform that he has developed both within this project, and he will be doing further development work on that after this project. He'll be presenting for about 30 minutes, and then towards the end we have about 20 minutes for questions and answers. Next slide, please. Okay, Alastair, who will be doing the presentation today, is co-founder of Open Systems Lab. So they're an R&D company based in the UK. They've already got projects. Some of you may have run across their WikiHouse project, and I think Alastair will be talking about this later on, but I think they're launching another version of WikiHouse in the next few days, so he'll probably fill us in on that. He's a very good presenter and speaker. I'm doing this so that I can make him feel embarrassed before he's even started, and then things can only get worse. But you'll find it's a very interesting presentation on a very interesting subject. It's a challenging subject, but he'll give you a background to what they're doing, why they're doing it, and how they're doing it within this project. Next slide, please, Colin. Okay, running through very briefly, as most of you know, 3CEA and Open Systems Lab are involved in a Northwest Europe project called Housing 4.0. And what we're trying to do is to use new innovative digital technologies for design, manufacturing, and assembling components for houses. We're looking at low carbon materials as well as low carbon consumption within the house. We're developing an H4.0 benchmark, and we're trying to look at designs that are not only energy efficient, but also improve the quality of life. Next slide, please. These are the project partners. You can see third from the bottom, OSL UK. So it's Open Systems Lab who are doing the presentation today. For those of you who were on last week, you remember we had a really good presentation from Stefan Thoma from Austria, which was actually on timber solutions, on timber components. Next slide, please. We were originally to put in housing units, trial sites, in counties Wexford, Carlow and Kilkenny. For various reasons, Carlow and Kilkenny are the only two going ahead. Wexford won't be going ahead. Carlow and Kilkenny have already started on site. Those contracts were awarded approximately a fortnight ago, and we were just in the process of putting time-lapse cameras onto them to record their development over the next 6 to 9 months. We've been working closely with the county councils and have had great support from them. For them, it's an innovative project, which isn't easy for them because their natural default position, because of their funding status, is to just meet the minimum requirement. But both Carlow and Kilkenny have been really supportive and enthusiastic about being involved in this. What we're looking to do is to work on small social housing units to save 60% of carbon emissions, but also to save 20% of cost savings in the long term by adopting this style of construction. Next slide, please. Objectives. What we're trying to do is to adopt the passive house and low carbon approach. And Alastair will be talking about the components and the design of the building that will help us to do this. Second bullet point is the platform as a support for planning, designing, and manufacturing. That's what we're talking about today. So he will also be talking about material and technology research. That was very relevant to last week's presentation. And another of the presentations later on will be about business modeling and implementation. Next slide. Okay. One of the things that you've heard me say before, and for those of you who haven't been on the previous seminars, what we're looking at is both operational and embodied CO2. So you'll all be aware that there's a focus on energy efficiency and on running houses and other buildings with as low an energy demand as possible. But it's only relatively recently that there's been a focus on embodied CO2. How much have you already built in to the concrete that you poured in the ground, or to the concrete bricks or blocks that you're putting in the outside skin? So that's what we're looking at. We're looking at the passive house approach to try and obviously save operational CO2 as well. But one of the most important things is what's called first fabric approach. Is what materials are you using, because they have not only an immediate impact on your CO2, but also a long term. Okay, you'll be glad to hear that's the end of me. I'm now going to hand over to Alastair. He's got about 30 or 35 minutes. I would encourage you to ask any questions in the chat as we go, and we'll try and pick them up at the end. Alastair, thank you very much. Over to you.
Thank you very much. Let me first do the bit where I get my screen shared. Good morning, everyone. There we go. A bit of luck. Please tell me if you can't see a big thing saying Housing 4.0.
No, you're sharing. Alastair, thank you very much.
Brilliant. Thank you very much indeed. Cool. So yeah, thank you very much for inviting me. Although very grateful for Michael's very kind introduction, in a way I'd like to start with getting some caveats in early. So whilst the first thing is that obviously we will be, the context of this is that is this piece of software technology that we've been developing, and we've been sort of working and thinking about this for a very long time, but particularly developing it through this the Housing 4.0E project. It's very much a work in progress, and it's a continuous work in progress. So the way that we work when we're building software isn't sort of to make a big bet where we think that we know what, we start with a kind of hunch of what's possible and what we think, and then we kind of work in what's called an agile way, in an iterative way. So constantly kind of learning, trying stuff out on people, releasing it, trying, and then listening to what they say they want, and then rebuilding it. So the stuff I'll be sharing is very much in progress, and that will be very evident from the stuff that I show. Nonetheless, what also I will try to do is talk about it from kind of first principles, so that even aside from the thing that we're building, hopefully those principles themselves will be a kind of a useful way of thinking about this whole space, really. And I imagine this is probably a space that a lot of you already know a lot about. So I guess I should also put in an apology that I'm going to try and talk about it to some extent from first principles. But a lot of that will probably be familiar to a lot of you already. So yeah, those are all my disclaimers from the outset. So as I say, this is us. We're a slightly weird thing to be. We're a non-profit R&D lab focusing on innovation for the built environment. As I say, that's included DfMA systems, so particularly WikiHouse, which we call DfMA, so Design for Distributed Manufacturing and Assembly. We're really interested in some of the kind of systemic challenges that underpin kind of all bringing ourselves collectively into the future. So as I say, we're non-profit. Our objective is to try and kind of change and build stuff that's useful for the whole industry. And that includes work we're also doing on digital planning and digitizing and modernizing the planning system. So very big picture, the context, I guess none of us need to know this, the sense of crisis, the world seems to be on fire, basically. But you can frame this many ways, but we all know the kind of challenges that we're trying to tackle. And of course, it's a perfect storm of challenges, right? So we know we need to build in the face of these rapid land price inflations. We know we need to be building more affordable tenure homes. We know we need to be using that effort, if you like, to kind of as a tool for local economic growth, and that's a big deal. Like, we need, if we're modernizing the construction industry, I strongly believe that has to be about SMEs and small businesses, not just centralizing. So we end up with just one kind of Amazon or Uber for construction, because that's a kind of dystopian future as far as I'm concerned. And then, of course, the climate crisis, right, which Michael's already touched upon. We need to be building zero homes that are zero energy in use, cheap to heat, using a fabric first approach, and zero embodied carbon. And we need to be doing this yesterday, basically. So fine. The bad news is, at the moment, most of the construction sort of approaches that most of us are used to using aren't really fit for that challenge. They're not going to serve for that for the next sort of few decades, and if we're going to achieve that. We know that construction buildings account for 28% of all emissions in their use. So obviously that's a retrofit story as well as a construction story. That is much more a retrofit story. But they also account for 11% of emissions in construction. So there's embodied things. The blunt thing of that is basically we're going to have to build with wood. It is the immediate thing. There's lots of other interesting innovations, but wherever possible, we're going to need to shift from using concrete and brick, because your typical house today has an embodied carbon footprint of between 30 and 50 tons equivalent carbon CO2, whereas actually once you're building in timber, provided that timber is sustainably forested, your homes are actually carbon negative. They're actually removing carbon from the atmosphere. So that obviously has been one of the big drivers behind DfMA. Ireland, of course, has quilture and does an increasing amount of growing as well. So I hope Ireland has some pretty cool resources on that front if we can use them. And these other things as well, which will all be familiar to all of you. The amount of wastage, etc., the kind of cost of errors. We know that most projects run out over budget and so forth, and I'll talk a bit more about that. The way that we build houses hasn't actually changed that much in quite a long time, at least not fundamentally. In the sense I always describe it as a bit like if when you went to buy a new car, you asked all the designers and the engineers from BMW to come to your drive and sketch the thing and build the thing right there on your drive in the rain, you wouldn't expect the car to be much good, and you'd expect it to be colossally expensive and hard to predict the cost of it. So we still have this very kind of bespoke approach to making buildings, where every single one is sort of tailor cut and crafted on site. And of course, the other sort of issue that's forcing the hand, particularly obviously in the UK post Brexit, certainly amplified by Brexit, is of course the skills shortage issue when it comes to traditional construction skills. So that's another one of the driving forces, pushing us all towards DfMA. So, as you say, there's lots of different words for this: modern methods of construction, DfMA, offsite. It doesn't really matter. We're all talking about basically the same thing, and in simple terms, that thing is what if we built houses more like the way that we build most of the other products in our lives? And there's certain principles and well-established sort of bodies of knowledge about how you do that. So the idea that you can think of a thing like this as having material, part, assembly, product. So beginning to think of houses as products is pretty kind of crucial theme here, and yes, kind of an open conversation. Or here's a slightly more a kind of complex one with a car, where you have materials, not just materials, parts, sub-assemblies, assemblies, systems, cars, products. So if you applied that to a house, it might look something like this. And there is no one way of skinning this cat. But broadly speaking, the idea that you manufacture these components and then you can you rapidly assemble in a factory or whatever it might be. This is another really, really useful sort of general lens for DfMA. This is based on a diagram originally done by Frank Duffy at DGW, which is to think of buildings as having, we've modified it a bit, as having these 7 shearing layers. Now, the important thing about these layers is that they all change at different speeds during a building's life. That was their kind of original focus. But actually, it's really, really helpful when we're thinking of buildings as products, because if you can treat these things as separate interoperable systems within a building, in the same way that, for example, the wiring loom in a car is a separate system from the gearing system, which is, you know, a separate system to the heating. Like, this is a really helpful thing, because some of them can be made very, very predictable, and some of them can't, namely the site, right? Site and groundworks will always be the crucial thing. So one of the big shifts in the way that we construct and the way that we procure buildings, which is really hard, because of course our procurement systems, particularly in the public sector, make it really hard for us to do this. But very much we're going to move more and more towards procuring groundworks and the buildings totally separately. So you'll have kind of these groundworks, foundations, service connections put in well in advance of the houses then being assembled. And also, the thing is, as much as people will tell you to the contrary, there is no one right way of doing this. There's a whole diversity of this. So, you know, and again, in WikiHouse, we take a particular approach to this. You know, how do you do it? How much do you do in the factory? How much do you do there on site? There's let many flowers bloom, right? There's many possible approaches to this. And it's fantastic that we're seeing the scale of innovation that we now are. And our emphasis was, oh, right, but so what do all these have in common? What are general principles that can work across all of these? And yeah, we'll have all seen loads of examples of the different versions. So the classic one people think of is volumetric. We have a multi-million pound factory. I think this is Swan or Ilka in the UK. This is in Sweden, Skanska Boklok. It's quite an interesting one, made of recycled plastic bottles again. So this would be more in the panel typologies. This is really interesting work called Shed in a Box for GlaxoSmithKline by Bryden Woods. And the idea of these were kit sheds for pharmaceutical companies that could be built. Actually, they were built by former Gurkhas, so not traditional construction workers. I personally don't think there's that. I think 3D printing is overhyped and not actually that useful, but I'm sure it might have some useful use at some point. I'm very excited, on the other hand, about the idea of plug and play service looms. With built-in self-diagnostics and stuff. We don't really have them yet in this country, at least. The Belgians have a couple of companies doing them. We have in commercial construction, they seem to be a thing. Maybe some of you have encountered them. And of course, yeah, many else besides the sort of block, like Lego sort of like approaches. We've got Thermo House here. Of course, obviously, I have to mention WikiHouse, and as I said, we particularly are developing this. So actually tomorrow we're going to be launching, after many, many years, very exciting, we're going to be launching WikiHouse Skylark, which is the latest version of this timber-based, it's an open source building system that's designed to be manufactured in very small factories and assembles very quickly. But what we're really interested in is that the same sorts of principles can apply across all of these systems. But if these systems are so good, the question begs the question, why aren't they being more widely adopted? I think a lot of it comes down to understanding the process and the design process, and particularly knowledge. I'm always fascinated by this graph. So this is based on public sector framework data in the UK. So what this graph is essentially showing is that for every euro or pound or whatever that we spend on a building, only 51p makes it into the actual building itself. Most of our money is spent on the right-hand side on overheads, fees and risk. Now, we don't mind profits. Profit's good, right? But the other ones, the cost of risk and the cost of overheads it's a bit mental. And how often do we find ourselves in a situation where you're value engineering the left-hand side of this graph, making the building worse instead of being able to squeeze down the costs on the right-hand side of this graph. Now, one of the reasons for this, I think, is essentially to do with knowledge, which is that buildings, as I always say, are technically less complicated than aircraft, but politically more complicated because there's a lot of stakeholders. So if you are a local authority, a developer, a housing association, self-builder, whoever, someone with land who wants to build something, between you and there is this fog of uncertainty that is so dangerous and unpredictable and risky that they literally make TV programs about it. You know, if grand designs wouldn't exist as a program, if everyone was like, oh yeah, we just stayed on budget, it was fine. And to navigate that sea of unknowledge, you actually need multiple sort of types of knowledge all at once. So in an ideal world, what we'd have is sort of all these knowledge about fire, knowledge about all these things, so you could make informed choices as you were designing. But that's not actually how it works. You know, and you could just say, right, I've got a costed design scheme, build it. But that's not actually how it works. Actually, what happens is that knowledge is pretty much trapped in the head of a string of professionals. And so when we design a building, we sort of design it sort of kind of backwards in a way, where the architect has to come up with a sketch, not knowing how it will be built or how much it will cost or how it will perform, and then say, right, to the planner, can I build this? Okay, and then to the engineer, will this stand up? Okay, how much will this cost? And every time it's wrong, you have to go back to the beginning and start again. So the net effect of this is that we don't just design every building from scratch, which is itself mental. We actually design every building from scratch several times over. And it also means that, of course, if you actually follow around an architect or someone who works in the construction and AEC professions most of the day, you realize that most of their day is not spent doing the thing. It's actually on emails and on the phone, arguing or shuffling liability at each other because of the huge riskiness of this thing. So it can really quickly balloon, especially, for example, once a project gets overrun and out of, over budget. Everyone becomes incredibly defensive and litigious, and we all know that. And of course, the way that people have naturally reacted to this is to come up with forms of procurement that try to black box this risk, which is completely sensible, but not necessarily always good for the design outcomes for the built environment. So next question is, okay, fine. If that's the thing, why hasn't technology already solved this problem? And to put it over bluntly, what we tend to do with new technology is we tend to sort of bolt technology onto our old ways of doing, our old operating system, a bit like putting alloy wheels onto a horse and cart. So even though we've got these, great BIM tools, digital fabrication, all sorts of analytic stuff, it's still basically proprietary software, or most importantly, software which is just being used by the same consultants who are in the same kind of legal relationship. So it hasn't fundamentally changed the order in which we design things, or the way that knowledge it flows through this system. So again, we're still there on the phone and in our email inboxes, is where most buildings are designed. The very few people would sign up for architecture school if they knew that the primary tool they would be using to design buildings would be their email inboxes. So the interesting question is, we think, this is a sort of the idea, if you like, behind this work that we're doing. We think that the most disruptive technology to potentially change this isn't necessarily technically, it's quite sophisticated, but actually it's already here, and it's the World Wide Web. So we've already seen the World Wide Web transform the way that we communicate, right? So, but because it is in lots of other areas, right? So for example, if you book a holiday, you no longer go and sit across a desk from a travel agent and say, right, they say, where would you like to go? And you say, well, what have you got? Right? We use the web as that sort of communication interface. We say, oh, what if we went there? Well, how much would it cost? And you can try things out, right? And that's really what we're exploring is, well, how could the web change this process? To kind of skip to the ending, if you like, of how we think the web changes it, combined with DfMA, it moves us in a future where effectively we move the design process the correct way around again. So instead of starting with a hunch and then guessing our way through to knowledge, we start with everything we think we know up to date, inscribed into products. So we start moving much more towards the idea that the first people in the process is not the customers per se, or the architect even. It's actually a DfMA product designers, and so I'll come back to this word designer, sometimes it's product manufacturer, but they say, we've come up with this, you know, Lego-like system, here it is, go and design with it. So, and then they put it, what they do is they put it out there to designers, and what they need to be able to do is to communicate to designers quite a sophisticated bunch of things about the rules and limitations of that system. So, you know, the maximum span that it can do or whatever it might be. And also that, but the cost and performance data, or the expected cost and performance data is if you like, built into that, into that information. So if all that information were built up front, of course, it would be quite a minefield. I mean, you're used to sort of scrolling through the spec page of people's websites, but wouldn't it be cool if it was much easier, and instead we could bring that into design configurators where you could literally play with designs. You could take standard patterns and start building and develop sort of trying things out on your scheme. And as you're designing, you're immediately seeing reasonably good estimates or reasonably good guesses about what the impact of your design, of that design decision would be, for example, on the cost, or for example, on the energy performance, based on the best data that we have available. And we could, you know, you could build more and more funky functions into it. What you'll see in a minute is ours is being very, very crude. But we could, you know, you can build in energy calculators, you could build in, you can use location data that we now know about the site to do that. You know, you can do all sorts of cool things with it, but, you know, the possibilities are endless, really. But we're like, let's start somewhere really basic. And what that would enable you to do as a customer or as a project architect working on a specific scheme for a customer is you could very quickly try stuff out on your own time, with some reasonable sense that, oh, that's going to work, right? And oh, I see, that's going to be the cost implications. And then when you're ready, you say, right, manufacture it, and then installers rapidly install it and bring it to site. And then, of course, the cool thing is that we then would want to capture the data from those projects to feed that back into the model, so that the next person has got up-to-date cost and performance data, so that those estimates get better and better and better over time. So I will now give you a very, very, as you see, it's very crude, very ugly, but I'll give you a current demo of what the kind of the tool that we're building currently looks like. You can go and try this out yourself for H4.0E. As I said, full caveats, all we're doing here is just working in the open. So we're working on a thing, we're playing with it, we test some out, but it's all there online. So you can just go and fiddle with it and play with it and think, oh, what would I want this to do? What kind of output would I want? So forth. So the first thing that we always do is start with a location, because that tells you all sorts of things like what, you know, is it even available in your area? Let's type in Kilkenny in Ireland. And look at the green. I mean, I know it's a cliche, but Ireland really is green, isn't it? Let's say we managed to, with apologies to the farmer, let's say that we just managed to buy this plot of land next to this house here. There we go. And let's go over into building mode. So what we can see here, or should be able to see here, hello, something's amiss. You can see here, this is where we need to never trust a demo. Try that again. I think it didn't register the boundary very well. Okay, won't bother. We should be able to see the site in here, but it looks like it's not going to play ball with me. Always the way when you try and demo a technology, that it decides to do something weird on you. Okay, we'll stay in here for now. Yeah, we should be able to see the site outline in here anyway, if I'd done a better job. But then what we can then do is go, right, okay, let's pull some, and we've got a couple of sample systems here. Again, this is all very kind of ugly and crude. And we can pull some preset house types. So this is an interesting thing, is obviously in theory you don't really need a house type. The system will have its own rules, but in practice people might find it helpful to have some sort of template houses to start with. And here again, I'm very going to quickly kind of show you some of the features, these menus, doing lots of work over the next month or two to improve these menus, but really simple intuitive design interactions to change the size of these houses. We could say, right, let's add some windows over here. Shall we change windows? Look, we can have this one. Yeah, there we are. We've added a window. And what you can see is as I'm making these changes, these metrics in the corner, the estimated build cost, operational CO2, et cetera, are updating live as we do it. We can also do stuff like changing the materials on the facades. I don't know if we've got any. There we are. We can say, I don't know, profile steel, whatever. Don't know why. We've just got some. These are just some example stuff in here. You can see it's very simple. We've also been playing with things like the ability to add stories, so make it a kind of a two-story house and so on and so forth. It's a very strange house. We'll obviously now have to go and put some windows into it. Seems nicer. So there we go. Right. So, and you can see, and what we haven't done yet is started looking at ways of configuring internal layouts. But this, for example, is the mobile team. They've got a manufactured house system that they're putting in here. And again, you could do the same thing here. So these are two completely different types of building system with completely different rules. As what I'm doing as a designer is very rapidly working within those rules, and it's not letting me do something that the system won't allow me to do, if you see what I mean. So it's saving a lot of time spent on the phone, et cetera, et cetera. And we can do funky things like section cuts. And anyway, you get the basic idea. And so one of the things we're going to be doing over the next couple of months, hopefully, is also adding more customization around internal layouts, because obviously it's fine to say change the external cladding materials, or obviously at some point we'll make it prettier as well, but that's, you know, start ugly and working is a good place to start. You know, changing internal layouts is obviously a really big thing that people want to be able to do based on, so adding a room, et cetera, as well as sort of changing the size of the building and changing windows and that kind of stuff. But what you're effectively doing there is pulling on a kind of menu of parts, a kind of, yeah, a menu of blocks that the manufacturer or rather the product designer has created in advance, and sort of, so you're just kind of like, yeah, configuring them. And of course, there's lots more that we could do to be much more kind of sophisticated in future in the way that you do energy modeling. So for example, the energy model at the moment, which Southwest College have been working on, is it doesn't yet, for example, factor in glazing areas and the direction those glazing areas are facing, which we know is obviously a quite significant factor. So we could, you know, what we're exploring here is a basic tool with the basic principles that we could then enhance the usability and the features of. The really interesting takeaway is, whether it's this tool or whether it's another tool like it, whatever, right? So if we begin to imagine the kind of, these kinds of tools are more and more becoming common, it does have implications for the kind of the roles that we play, and this is true of DfMA generally. So as we say, the key roles is this emergence of this new role of what we would call product maintainer or product manufacturer. So we think of architects as being the only designers, and I don't think that will split. So you'll have the kind of the designers of the product, of the building system, which is often in-house in the manufacturer, but not always. And then you'll have the designers of the scheme, of which will be more like your traditional architects, and it's just that they're specifying, you know, a DfMA product as opposed to specifying bricks. or whatever it might be. So some of those relationships will change, and again, ways don't have to go into that now. I think there's lots of stuff that's going to shift on procurement, because the way that we procure, particularly in the public sector, is yeah, quite sort of built around the current way of building. Just finally then, just to kind of go out, I'll quickly give a little insight into how that product was documented and put in there. I'm interested to hear kind of people's views on, if you're the sorts of person like the bottom, you know, the project architect who might be using that, or a customer, we're very interested in questions like, what kind of files would you like, if you're going to use something like that, would you like to be able to just submit that to your manufacturer and say, hey, we want 3 of those? Presumably you'd want to be able to export some files like 3D models or something like that you could then use to make your planning application, or so interested in those sorts of insights. But we're really aware at this point, we're really looking for, as we develop this project, the initial manufacturers who are creating these manufactured building products and are interested in putting them out there in this way. So I'll just talk a little bit about how that works. The challenge that we faced here is coming up with a system. So there's some people doing some really, really interesting stuff with very, very sophisticated software. And actually, we, you know, like H4.0E is a really interesting company right now. We know them quite well. And they're going like full parametrics. And we're very much 80-20 rule people. We're like, well, actually, do we need that degree of full parametric control? The advantage of the parametrics, of course, is you can build almost anything with them. So we said, right, we've got to give it enough flexibility that we could deal with most types of 3D printed, sorry, except possibly 3D printed, most types of DfMA product. The other thing that we encountered is that companies were in very different places in terms of how the granularity of performance data and costing data that they had, and indeed the granularity that they really wanted to expose. We obviously do everything open source, so we just publish everything warts and all, but not all companies want to do that, and that's fine. So we said, fine, we might say that actually we want to make sure the system is usable, not just for a whole range of different types of modular system, but also for companies who might not want to kind of have to enter all the data shown in level 4 here. Potentially they might only want to enter the level of data in level 2 or 3. And we had to find a way to do that. And the answer is that we come up with is probably not a surprise to anyone, is this concept of modules. Now, modules don't have to be literally modules, i.e. they're not literally parts of a building that you can crane. They're kind of an abstract concept. They're sort of a bit like the concept of a grid in design, which is that they are the kind of the building blocks of a design that you can kind of switch out for each other. And weirdly, what we discovered was that if we ask every that modular system, you know, can be any grid you like. So we all know Lego, right? Lego is based on that little circular dot unit. So it doesn't matter whether your unit is 5 centimeters or, you know, 5 meters. It doesn't really matter. We can make the system agnostic to that, but the thing it does require you to have is a unit. So in some way, to be able to break your building system into some kind of module that is and then effectively we realized that all we needed to do, I say all, haha, is for product maintainers to essentially put all of those modules into a kind of library, like a menu, and enter just enough data about them that the platform knows where to put them and where users are allowed to put them when they're designing. They also actually give some sort of generic system-wide rules, like the maximum height, number of stories, and things like that, the capacity limits of the system. And then once we did that, we realized we could come up with this kind of universal like grid system, which allows us to describe any building almost like as a string of DNA, so that you could then combine those modules in a huge number of different ways, so that although the user is getting the experience that they want of like, right, I want to make my building bigger, I want to add a bedroom, I want to change the windows, actually what you're doing behind the scenes is just switching out one Lego piece for another Lego piece. at any degree of detail. And at the moment, the interface that we're currently using is actually rather hacky. We're actually using an Airtable database, but what we will be doing over the next few months is actually, for the first time, because it works, right? But we will be building an actual proper interface and testing that with product maintainers to upload. So they'll be able to upload their 3D models of each module and then enter just a few key pieces of data about that module, such as its cost, its expected embodied carbon, etc., etc. Later on, they'll also be able to add a bill of materials and things like that. So, but it is hard because the challenge that we're putting to them is you need to think in modules. You need to be able to break down your product into a series of standardized replicable modules. So for us, you know, hopefully you've got some interesting questions, but in a way I'd like to put some questions to you. So I kind of, these are the kind of questions I'll sort of finish with, leave them hanging in the air, which is, yeah, like, in the current context, what's the problem that stuff like this you'd be interested for it to solve or to make better? Like, what are the biggest pain points to adoption for manufactured housing solutions for you, in your view? What information do you wish could be more transparent earlier on in the process? Because that's a big part of this, really. It's about moving knowledge from guesswork later to having transparency early on. So if you could know one thing earlier on in a project, what would it be? Then, you know, how could you imagine it using tools like this? What the bits of information you'd want from it, or the things you want it to do, but equally, where do you see your role in it? Like, what those emerging roles, which, you know, how, and then also, of course, what won't work? In which areas are we being hopelessly naive, and actually this technology will be completely useless? I'd be always interested to hear your views on that. And with that, I will shut up. Thank you very much indeed.